All right, so the first question says two blocks are connected by a string of negligible mass that passes over massless pulleys that turn with negligible friction, as shown in the figure above. And then it says the mass M2 is greater than M1, and blocks are released from rest. And the first part of the question says the dots below represent the two blocks and draw the free body diagram showing and labeling the forces, not components, exerted on each block. And it also says draw the relative length of all vectors to reflect the relative magnitudes of all the forces. So if I want to draw, like this is, let's say this is block number 1 and this is block number 2. And as we know, M2 is bigger than M1. So starting from, let's say, free body diagram of M2, I'm going to be drawing a longer vector for, for the weight of M2 compared to M1. And then also we have tension in the string because the blocks are attached to a string. So we're going to draw the tension, and then the tension is the same for block 1 and block 2. The reason they are the same is because they are basically connected through one single string. So the tensions need to be the same length. Hopefully that shows it. And then M1G needs to be smaller than M2G just because M2 is bigger than M1. So having said that, so basically this just answers part A. And now part B of the question. Part B of the question says, derive the magnitude of the acceleration of block 2. Express your answer in terms of M1, M2, and G. So figuring out the acceleration of block number 2, essentially what we need to do is that we need to utilize the Newton's second law, which means F net equals ma, which here is m2a. And just taking a look at the free body diagram for block 2, we see that M2, so basically M2 is bigger than M1. So the system moves this way. So if the system moves this way, that means M2G is going to be bigger than the tension. So M2G minus tension gives me the acceleration in A. And this is for block number 2. And in the system for block number 1, what we have is that if the system moves to the basically clockwise, moves to the right, then that means T is bigger than M1G. So that's going to be T minus M1G equals M1A. So I'm utilizing essentially the same Newton's law that I use for block number 2. If we take a look, we can see that we can actually add the two equations together to get rid of the T. So adding them up, M2G minus M1G equals M1A plus M2G, right? And then we can just, this is M2A. I don't know why I said G. Sorry about that. And then factoring out the G, so M2 minus M1 equals factoring out the acceleration, M1 plus M2, and hence we can get to know the acceleration as M2 minus M1 times G over M1 plus M2, and that is the acceleration in terms of M1, M2, and G, and that should take care of it. So that's essentially satisfies the question that we were asked about. And now part C of the question, it says Block 3 of mass M3 is added to the system as shown below. There is no friction between block 3 and the table. So for part C of the question, because I need to explain a little bit more, I'm going to end the video right here and I'm going to start part C of the question right after this video.